Right. Hi everyone. What you're looking at over here is a Python port of CUFSM, which was originally written in Python by ClearCalcs, and right now it's my repository that has a Jupyter notebook. So we're going to continue from here. This is the notebook that we are interested in, and this notebook has some very rudimentary features for conducting general signature curve analysis only, and you can open this in Google Colab. Google Colab is a research project by Google where it has set up a Jupyter notebook environment for that runs completely on the cloud, and it is free to use. The limitation is that you can use it for up to 12 hours straight. Yep. So here, since it's running completely on the cloud, you need to clone the GitHub repository into the drive here, and you can run this cell. The shortcut to run the cell is Control plus Enter. Oh, first mistake. So username here is wrong for the moment. You won't have to change that. Cloned correctly. Now we move on to the preprocessor cells. First one is our cross section, where we define our properties, nodes and elements, springs, constraints, the doubler feature, and calling the cross section. So once we run this cell, we can see what our cross section looks like. Say we want to add another node onto here, onto this. We take this entire row here, and all right, not going my way there. So this should be changed to number 10. Notice that index starts from 0 because this is Python, and let's shift node 10 from node 9 by 1 inch. This is the x coordinate, y coordinate. This is our x DOF, z DOF, y DOF, q DOF, and stress at that node respectively. And similarly, once we add the node, we need to add the corresponding extra element. That's element number 9, connecting node 9 to node 10, having a thickness of 0.059 and the material number 0 defined over here. So let's run this, and that was a huge increase. All right, so 7.27, that looks better. And let's try 0.1 thickness for our 9th element. Over for fun, 1. Yep. Anyway, we're going to go back to this because we don't want any weird signature curves. Right, 0.059, correct. And this feature over here is the doubler, where you double the number of elements between each already existing element. If we comment out this line, the way to comment out a line or a block of lines is highlight and to press Control plus / and run this again. All right. So next cell is to specify the lengths at which you want to conduct your analysis. You can manually input each length that you're interested in, or if you want to generate n lengths equally spaced between a and b, use this, and if n lengths log space between 10 raised to a and 10 raised to b, use this. So We're going to try one of those codes, comment this out using control plus // take this, copy, starting from 10 raised to 0 to 10 raised to 4, interested in 100 lengths, run this cell. Next cell is boundary condition selection. So the available boundary conditions we have are these 5, and each of them have a key. So based on which boundary condition you're interested in, you have to specify the key over here. We're going to continue with simply supported. Next line, do not touch if you're just interested in signature curve analysis. Third, over here is a number of eigenvalues that you're interested in. Let's run this cell, not changing anything there. Next cell generates the stress at each node based on the kind of loading that we're interested in. So say let's just run this code once, check the default, and there you have a bending about the x-axis here because you have specified coefficient 1 over here for mxx. Say you change that to bending about y and change this to 0, you have stress generated accordingly. We're going to go with compression force only for now, and there you go. You can specify a restrained analysis as well, so you change that to true. We're just going to go with false for now and run this cell again. The flag array that you see over here is to change your plot options. Say you're interested in the element number as well, so you switch this on. They're in the same order as specified in the comment over here. So if we run this cell now, we can see the element numbers as well. Looks a bit crowded, so I'm just going to keep it out. And this cell is to analyze, is the analysis cell where you conduct the finite strip method. That has run. Next one is post-processing cells. First cell, signature curve, control enter. So you can change the modes that you want to display. You can change the plot limits. Say you want your Ymax to go up by 5. There you go. And say you want to display your second mode. There you go. Say you want to display first and second mode. Then this is how you go. Say 1, 2, and 3. All right. That's about it for the signature curve. And next cell, display shape. So control enter, default. You can change the mode number to what you're interested in, and say 2. All right, you can change the length index that you're interested in, say 100. That would typically give a global buckling curve. And one back. All right, looks about right. And the next variable we have over here is scale. Say you want to scale the figure another. Wow, not looking good. All right, 3. Whatever scale you want. Looks like 10 is the limit. Don't do that. All right, that's about all the features we have in CUFSM Jupyter notebook, which you can run from anywhere having an internet access. All right, thank you.